Hey everybody, this is Larry. This is me actually doing a part two, I guess, of yesterday or earlier today's problem. Build a way where you can find maximum exactly k comparisons. I don't know how many of you gonna be able to find this video. Hit the like button, hit the subscribe button, join me in Discord, and send it to your friends, I guess. I think the thing about this particular problem is that, or I don't know, the problem name is long, so I don't know if you're gonna be able to find this video, but if you do, leave a comment. So maybe I'll do more of this stuff in the future. But okay, so I think I should have done this on the original video, so that's my fault. I don't know, I just didn't think that much of it. But the idea is, and I actually in the original video, which have a link in the comments, just because why not, is that I actually kind of was talking about how you can, kind of find, you could kind of optimize it. I kind of alluded to it in the beginning, but I didn't really go into it mostly because, to be honest, yesterday I was just pretty tired. I did physical therapy or something like this, and a couple of things, so I was just tired. I don't know if it's a good excuse, but it's an excuse. But the idea here, I see it called as a prefix sum, which is maybe fine, but but I actually don't think of it as a prefix sum. Or I mean, you have to use the visualization that is most helpful for you. And for me, I actually don't think about these as prefix sum. I think about it as loop caching, as used to call it back in the day. I don't know if that's the technical term, because I think back in my day, a lot of these competitive programming, quote unquote, tips and tricks or whatever don't really have a name. People just did them. So but nowadays everyone is obsessed with names and patterns and all these things. So you have all these names that, like, I don't know, when I was learning these things don't have names, like sparse table or sparse array, and binary lifting, all these funky things. Anyways, so okay, so for the rest of this video, I assume you've watched yesterday's video, or for me it's yesterday, but whenever you watched it for part one of this video, and you understand the solution. Hopefully, I don't, that is the prerequisite. You have to understand it. I'm not going to do a second video basically doing the same thing, because that's a waste of your time and my time. I guess more of my time, because you can fast forward. But the idea is, okay, now you have this. Can you think about optimizing it, right? The way that I would think about it is, okay, well, what will we optimize? There's a for loop here and a for loop here that gives us kind of complexity. If we can kind of make this O of 1, this and O of 1, then we'll at least hit lower bound instead of time, right? Well, what is this function, right? Let's take a look at this for now, and then we can kind of figure it out, right? So basically, you have something like, yeah, I'm just double checking. So like I'm gonna call it f instead of k. I'm just short it to right. Is equal to basically sum of f of n minus 1 mx k, right? Well, this part is just dumb, I think, for my part. To be honest, I just realized this. So right off the bat, I think the reason why I didn't do this optimization earlier is because I think I wrote this incorrectly in yesterday's video, or the part one of this video, as you may recall. So yes, I didn't do it that way because, like I said, I did it incorrectly, and I was like, oh, you can't really take that out. But now that you can see it, you do this. Well, how many times do you do this? You go from 1 to mx inclusive, so that's exactly mx times, right? So you can actually just already reduce this to that, right? And of course, in TDD style, let's make sure that it works. Let's give it a quick submit first, just to make sure that works, right? And now we can already see that we already kind of optimized it half away. Overall complexity is still not fixed, because this can still be O of m, so you still have the same idea, right? But okay, so at this point we already optimized this part. I thought I was thinking about doing it during the contest, but I think I just missed it for some reason. But yeah. So then now, okay, so now this is mx times this instead, right? Plus, and then you have some sum of f of n minus 1 x k minus 1 for x is in some in range, right? In mx plus 1 to m plus 1, I guess inclusive would be like this, right? So this sum, right? So what can we do here? So that's not this is already an optimization. It's already cool. It's already kind of nice. there is another thing that you can do, and as I was saying, it's called loop caching. And the idea is that, okay, now you're trying to figure out, I guess this is why maybe it's called prefix sum, or other people could visualize it as prefix sum. I still don't really, I just call it loop caching. But the idea, the prefix part comes from, okay, let's say you have this, right? Then this summation is just this summation. And okay, so then what do you want to do? So basically the problem, or the thing that you're trying to optimize for this function is that this does an O of M loop in the worst case, right? So how do we get away from that? Well, we can just make sure that this calls one thing, right? So for example, now we can do something like C, let's just say function, naming things is hard. So let's just say maybe count sum of n minus 1. Let's go up to well, in this case, this is not quite right, and I'll show you why in a second. But let's say we have something like this, right? And then, okay, let's skip back for a second. Let's say we have this, right? Yeah, and then this will get us, something. And here we can maybe do something of count sum of n, m, and k. And basically the idea is that now you're caching things in a way such that you have a loop built into the cache, so that you only make one call instead of two calls. And what there are a couple of ways you can maybe think about it. It almost is like that optimization with tail recursion, but the opposite of it. That's how I kind of want to think about it generally, is that you have that tail recursion, but instead this is the opposite of tail recursion, is you're putting the recursion back instead of unrolling into a iteration thing, right? So what I mean by that is that how do we define this in terms of itself? Well, this is just Leetcode 2 count sum of n, m minus 1k plus count of n well, in this case it's just n. It's a little bit confusing, I know. M and k, right? So basically that's basically the idea, right? And you can think about it in a number of ways. I mean, if you kind of unload this with tail recursion, right, then you can kind of see this is how m1k plus count of m2k plus count of m3k plus ... plus count of nmk, right? So that's basically what this count sum is trying to do, and you have this kind of loop thing, right? And yeah, and you can kind of see that, like, at this point, you know what I'm going to do, right? With some idea. You know that I'm going to add memorization, so that now this is instead of, so instead of doing a for loop, because if we don't add memorization, then this is just going to unroll all these things. But then now if you do add memorization, then this is always going to be amortized O of 1, and this is O of 1 amortized because we cache it as well. And then as a result, this is just going to be O of 1 together, and now this is how you get O of 1. Well, almost, right? So we're almost done. And then the other idea is that, okay, well, this works if we're counting from n1k all the way to nmk, right? But we're not. We're trying to go to mx1 plus, or mx plus 1, right, in the middle. So, well, hopefully you're getting a little ahead of me. But the idea then is that now we trying to get some subtraction going on, and this idea is, I suppose, very similar to prefix sum, right? So then now you have some of this plus count of n of mx k, right? Maybe I'll delete the 3 one. We need that, right? Something like that, say, right? And here the idea is that now if you subtract this from this, then now you have the sum between n mx plus 1 all the way to k, which is what you want from here. So then it is going to be this minus mx, right? Because you want to include mx plus 1, so you want to subtract mx from it. So that's basically the idea behind, and of course you have to do the mod. And that's basically the idea behind, and you can kind of run this. It's still, oh, I didn't have a base case. If I had a base case, this should work. But if m is equal to 0, I think we just return 0, right? And that should be good, right? When we do list of index, maybe I have an off by 1 here because I think maybe m plus. Oh yeah, this is not m plus 1 because the for loop has an exclusive thing, right? So that's why. But yeah, and we can just kind of do a quick submit just to make sure it works still by TDD, right? Maybe it's a little bit slower because I forget to. I should probably mod it more often. But yeah, so this is a little bit, well, this is actually a lot slower because we haven't added caching yet. And this, this is a lot more function calls and stuff. A for loop is pretty fast in general. Doing recursion, you're adding call stack and all these things. And this stack also calls back this thing. So it's not quite, I don't know, there's a lot of function call, a lot of overhead. So this is slower. Not that shocked, to be honest. So yeah, but now, once we add memorization, this is much easier, right? So then now, yeah. Let's move this down here. And then maybe just like write the same thing, but let's call it right. And then now it has some cache is of n k return some cache, yeah, right. And then now also we need to mod here. That's probably also why it's a little bit slower, because I think it's doing a lot of big num stuff. Maybe not a lot, but enough. The thing with Python is that it lets me get away with being a little bit sloppy on the modding, so yeah. Oh, I got it wrong, but okay. Right. Let's give it a submit. Hopefully I mean, it should work. It's just whether I forgot caching or something, something silly mistake. But yeah, but that's pretty much the idea of this quote unquote prefix sum cache is, just one step at a time. Now you're calling 2 functions, or I guess technically 3, sorry. You're calling 3 functions instead of O of m functions. So then now this goes to O of n times m times k. And there you have it. Yeah. That's pretty much it. And of course, I know people in the comments already made it. Why don't I just use cache? I think for me, I just like to write it out for the purpose of these videos because, then now you could see the space complexity very easily. And the time complexity also easily-ish as well. That's my story and I'm sticking to it. But yeah, let me know what you think. Let me know if I should do more of these optimization things. I kind of was just tired and lazy yesterday, which I apologize for. But yeah, as you can see, it's not... Like, once you have the right idea and visualization about it, it is not a tough idea. And for me, it is easier to kind of just write it the quote-unquote, the straightforward way, and then kind of be like, oh, it's just this, and then you can optimize it away, and then, instead of like, I don't know. And of course, that's just practice as well. I mean, if I do the same problem like 4 or 5 times in a row or something, I mean, I've done it more than 4 or 5 times, this idea. But let's say, if I've done it, more regularly, then I'll be like, oh, I recognize this right away, so let me just write this right away or something like this, right? And you could still do this these bottoms up. It's a little bit trickier, but the idea is not that bad. And again, you can also still use the space optimization after doing bottoms up, as you can notice that this is just n-1, and this one doesn't even use n-1, so you can just keep just the last n, right? So yeah. Anyway. Hopefully this is helpful. Let me show the top again, and let me show the bottom, and that's all I have for this one. Let me know what you think, and yeah, definitely hit the like button if nothing else, or leave a comment for these kind of videos, because I don't always do them because I don't know if there's any demand for them, to be frank. Like, maybe my other video is good enough, and I don't, I'm not going to do like 20 videos a day. That's maybe I could, I don't know. But if that's what people want, then maybe I could do it a little bit more. So definitely leave a comment. If not, then maybe this is a one-off and we never do it again. So I don't know. Let me know what you think. Let me know if this is helpful. Let me know if this is understandable. Let me know yeah, if you can optimize your code with stuff like this. But yeah, overall it shouldn't be so bad once you kind of recognize some stuff. So yeah, that's all I have. Thanks for watching. I'll see you later. Stay good, stay healthy, to mental health. I'll see y'all later and take care. Bye bye.